We're going to keep talking about graphing lines today. So we talked about last time how you can always graph a line if you know 2 points which are on the line. And I want to talk about some situations in which you can kind of make that easier for yourself. In particular, I want to talk today about something called the slope-intercept form for a line. And the slope-intercept form, which a lot of you guys probably have seen before, and this might be the form in which you are most familiar with lines, a slope-intercept form looks like this. Y equals mx plus b, where m here is the slope, and that means that we can compute m by computing the change in y divided by the change in x. So if you pick 2 points on the line, this is going to be y2 minus y1 over x2 minus x1, where the points are x1, y1, x2, y2. And then b is simply the y-intercept. So why is this form of a line so particularly nice? Well, the reason why this form of the line is really nice to work with is because it's easy to read off the information from a formula like this. And once you have that information, it's relatively easy to make a graph of the line. Why would it be so easy to make a graph of the line? Well, the reason for that is because if I give you a line, like let's say that I give you y equals 3/2 x minus 2, and I ask you to graph that line. Well, what I can do, instead of trying to find 2 points that are on the graph, I could do that too if I wanted to. I could just find a couple of points that are on it. But if I want to make this graph, one way that I can do it is I can say, okay, the y-intercept is at -2, and then the slope is 3/2. And one way to think about the slope, and I want to say that this is something you can think about with slopes and lines in general, the slope is really the rate of change. It's how much y changes per change in x. And what this means is that y changes 3 as x changes 2. So what does that mean? Well, it means if I go over by 2, I should go up by 3. So that means if I go over from the y-axis along the x-axis, so I'm starting here and I'm moving over to the right, so I go over 1, 2, and that would take me over to here. If I start at this intercept, the line should go up by 3. So I count up 1, 2, 3. And that takes me up to this point, 2, 1. And now I have 2 points on this line, and I can just connect them up. So the reason why this form of a line is nice for graphing is because I have the y-intercept. That immediately gives me 1 point. And if I know 1 point together with the slope of the line, well, then all I have to do is I start at that point, I go over along the x-axis by whatever's in the denominator, and then I change along the y-axis by whatever's in the numerator, and that gives me a second point. So let's take a look at another situation where we use this kind of method for graphing a line. Let's suppose that I ask you to graph y equals -5/3 times x plus 1. The way that I'm going to do this is I'm going to start by marking off the y-intercept. Now I can see that the y-intercept here is 1. Sorry, let me shift the camera just very slightly here. Okay, sorry for the delay. Anyway, the y-intercept here is just 1. So I mark off the point 1 along the y-axis where we're going to go through. And then what I see here is that As x changes by 3, y changes by -5, okay? So whenever I see a negative fraction, I like to think of the negative as coming from the numerator and the denominator as being the positive number. You could do it the other way too, it doesn't matter, but that way your x always changes positively, so you always move to the right. So what this means is that as I go over by 3, I'm going to go down by 5, because y changes by -5, and that means I would go -1, -2, -3, -4, -5 as I count downwards. I suppose I should put some tick marks on here. And so if I go over by 3 and down by 5, that gets me over to here. This is going to be the point 3, -4. And then these are 2 points on my line. So now I just have to connect up these points with a straight line. And there's my graph of my line. Another way that people sometimes think about the slope is they think about the change in y as the rise. In other words, how much does the line rise? Or if it's negative, then it would really be the fall, but we think of that as kind of a negative rising, okay? So that way we don't have to remember fall. And then divided by the run, where we think of the run as how far did we run along the x-axis during that rising or falling, negative rising, that we went through. So this is another way that some people think about the slope. Now, instead of asking you to graph the line based upon an equation, you could also be asked, find an equation based upon a graph. And you should be able to do that by similarly reading it off if you can see what the intercept is and what some other point is. So if I asked, what is the line graphed here in slope-intercept form, excuse me, wow, and I'm abbreviating intercept here so that I don't have to write the whole thing out. And let me just sketch a quick graph here. Let's suppose that our graph looks like this. So if I look at this thing, let's suppose that I know that this thing goes through the point 0, 2, and then it goes through the point 4, 1. Well, I can see here immediately that the y-intercept is going to be equal to 2 because it just goes through that point on the y-axis. And then I can see that as I come over here by 4, I come down here by -1. In other words, I run over by 4, and my change in y is -1. So we get a slope of -1/4. And this is going to give me an equation. Let's just write the equation over here. Y equals -1/4 x plus 2. So you can read off these slope-intercept forms directly from a graph if you happen to be able to read the y-intercept and also figure out what the slope happens to be. And that makes things reasonably straightforward to write down. So the slope-intercept form is pretty nice for this reason, and it's the way that a lot of people like to think about lines. It's simple, elegant, relatively easy to use and think about in a lot of situations. Unfortunately, it is not always exactly the best way to deal with lines. Okay, so there is another form for lines which can be, in some ways, a little bit, I don't know if I want to say easier, but see, it's a more complicated form, but what's nice about this form is that working with it can actually be more straightforward, even though it is a slightly more complicated form. And this other form of the line is called the point slope form. So what we want to say is the following. A line through a point x0, y0. So I'm going to use subscripts here to denote the point that we know that it goes through. With slope m has an equation of the following form. Y minus y0 is equal to m times x minus x0. Now, how do we see that this is true? Well, first of all, to verify that this is true, if I plug in x equals x0 and y equals y0, then this equation becomes true, because the left-hand side becomes 0 minus 0, and the right-hand side becomes m times, why did I say 0 minus 0? I'm sorry, I meant to say y0 minus y0, not 0 minus 0. I don't know what I was thinking there. I guess I was just writing the subscript instead of the actual symbol here. So y0 minus y0. And then on the right, if I substitute in x0 for x, I get x0 minus x0. But we see that this is just 0 equals 0, which is true. So my claim that this equation, this line, actually goes through this point is true. These values for x and y are a solution to this equation. So that's good. And then we want to see that this actually does in fact have a slope of m. Well, there's a few different ways of showing that, but to see that the slope is really m, we can rewrite this thing as y equals mx minus mx0 plus y0. And now I can see that if we let this whole thing over here be b, this is really in slope-intercept form, and we know that in slope-intercept form, the coefficient of x is just the slope. And so this is, in fact, the slope. Now, you might wonder, why would we bother with this if we have the slope-intercept form? This seems like a much more complicated way of writing things. Well, the answer is because a lot of times you don't necessarily know the y-intercept. You don't necessarily know where that is, but you might know the slope and you might know some point on the line. And the nice thing about this format is that's all you need to know. You don't need to specifically know the y-intercept to be able to use this thing, okay? All you need to know is some point on the line together with the slope. So, for example, if I wanted to write an equation for a line through the point, let's say, -1, 3, with slope 2, I can do that. So what I'm going to do is this point that I want this to go through, these are going to give me my x0 and my y0. And the slope is just going to be m. That's kind of the easy part. That's just automatically the slope, if you're given the slope. Sometimes you won't be. We'll look at that in an example in a minute. But then what I can do is I can say, well, this means that my equation is going to be y minus 3, because remember it's y minus y0, is equal to 2, that's my slope, times x minus -1, because the x0 is -1. And we can simplify this slightly to say that this is y minus 3 is equal to 2 times x plus 1 if we want to. I would say that, when you have negatives that just cancel so easily, you should do that. Okay, So what does that mean for us in terms of our answer? Well, it's perfectly fine to leave it in this form because this is in point slope form. So this is kind of one of the accepted normal forms for an equation for a line, and you're allowed to leave it like this. If we wanted to, of course, we could rewrite it into slope-intercept form. So to rewrite in slope-intercept form, what you're going to do is simply solve for y. In other words, you want to isolate this y. So what does that give us in this case? Well, that would give me y minus 3 is equal to 2x plus 2. And if I add 3 to both sides, this is going to give me y equals 2x plus 5. So if you wanted to rewrite it in slope-intercept form, you can do that just by solving like this. Now, there's other ways of going about it too. You could, for example, say, hey, let's just find the intercept by plugging in x equals 0 and solving for y, but it's just as easy to do it this way. Just like with slope-intercept, it is also possible to just like with slope-intercept, that is what I meant, you can read off point slope form sometimes if you happen to have a graph where you can read the point and the slope. But before we talk about that, I want to talk about another kind of problem that you could encounter using point slope form, where you're not actually given the slope, but where you can figure out the slope in a certain way. So let's suppose that we want to find an equation for a line through the points, let's say -2, 1, and the point 1, let's say -8. So how could we go about doing this? Well, the way that we're going to go about doing this is we can remember that the slope is equal to y2 minus y1 over x2 minus x1. I can pick either of these points as point 1 and then the other point as point 2 and use that to compute the slope. So I'm just going to pick this to be point 1. So this will be my x1 and y1. This will be my x2 and y2. It doesn't matter, though. I could have labeled them in the opposite order. It turns out to give you the same thing. And when I do that, then this gives me that the slope is going to equal -8 minus 1 divided by 1 minus -2. So that's going to come out to be -9 divided by 3, which just simplifies to -3 because I can cancel. The 3 divides the 9 3 times. So that is my slope. Now I can pick one of my points to be point 0. I'm just going to pick this as my point 0. So I'm also going to think of this as my x0 and y0. I could pick this point over here instead if I wanted to. So this gives me, if I go back, refer back to your notes here on point slope form, I would get y minus 1 is equal to the slope, which is -3. And then that would be multiplied by x minus -2. So this would come out to be y minus 1 equals -3 times x plus 2. So this would be my answer. This is a perfectly fine format to leave it in. An observation that I want to make, though, is that there is another possible answer here that's also semi-obvious to write down. And that would be, what if instead of picking this as my point, what if I picked this as my point? So what if I instead made this my x0 and y0? Well, that would give me a different equation, but it would still be correct. So I would get y minus -8 is equal to negative 3 times x minus 1. That gives me y plus 8 equals negative 3 times x minus 1. So what's going on here? We just got two totally different looking answers to the problem, and I said they were both correct. Well, the answer is these equations are equivalent. Remember, equations are equivalent if whenever you have a solution to one of them, it is also a solution to the other. It turns out that this equation and the previous one, the one that I erased, they are equivalent equations, and so they actually describe the same line. So, a given line can actually be described by many different equations, and this makes a lot of sense. We actually kind of already knew this because, for instance, if I put this equation into slope-intercept form, I would get, let's see, y plus 8 is equal to negative 3x plus 3. That gives me y equals negative 3x minus 5. Well, this is the same line, but rewritten as the slope-intercept form. But it describes exactly the same line. It has the same solutions, okay? So there are many different ways of writing down an equation that geometrically describe the same line. And it just comes down to the fact that you can take any true equation and you can rewrite it by doing algebra on it and get another true equation or another equation that is equivalent to the original equation. Hopefully that wasn't super confusing. The upshot of all of this is that when you have these two different points here, you calculate the slope by picking one point as the first point, one point as the second point. But it doesn't matter which one you pick. You will get the same slope regardless of how you label these. You do have to be consistent. The point is the first point or it's the second point. You can't like mix and match. This can't be x1 and y2. This can't be x2 and y1. But I could make both of these my second coordinates and both of these my first coordinates if I wanted to. The other thing is that once you do this, you also have to pick one of these as your point 0 that you're going through. So there's some choices involved here in how you do this, and some of those choices can give you a different answer. So you and a friend might both do the same problem. You might get answers that look a little bit different, but they may end up describing the same line correctly. All right, now going back to the situation with graphs and graphing equations or looking at graphs of equations. So what if I gave you this graph and asked you to find an equation for this line? And let's suppose that the graph that I gave you looks like this. That's not what I wanted to mark. Suppose that we go through that point and then we go through this point and you see a line that looks something like this, and we know that it goes through the point 1, 2. Actually, let me put the label up here. And we know that it goes through the point 3, 3. And I ask you to find an equation for this line. Well, you can't see from this graph necessarily exactly where the y-intercept is. You could probably guess, and we could figure it out if we wanted to, but, I mean, we'll see how you would figure it out if you wanted to. But what we don't know is exactly what it is just by looking at the graph, okay? Even if it's a computer graph, you can't really look at those graphs and be exact about it. So if we want to get an exact answer, we're going to have to depend upon these 2 points that we're given. Well, here's the thing. We've already done a problem where we're given 2 points and we have to find an equation for the line. It's not anything different than the previous example that we were doing. It's going to go the same way. So I'm going to pick this as my second point. So this will be x2, y2. This will be x1, y1. And then my slope here is going to be given by y2 minus y1, so that's 3 minus 2, divided by x2 minus x1. That's going to be 3 minus 1. that becomes 1 over 2, which is just 1/2. So this has a slope of 1/2. And that makes sense also if you think about it geometrically. You can think about the fact that this goes over by 2 while it goes up by 1. So if you kind of think about just reading it off that way, you could, without even working this out, if you just said, hey, look at the dimensions of this triangle, that would kind of give you the slope as well. And then I'm just going to pick this first point as my x0 and y0 as well. So that's going to give me y minus 2 is equal to 1/2 times x minus 1. And there is an equation for this line. So that's my answer. Now, if I wanted to, for some reason, find the y-intercept, I could do that in a couple of different ways. So one way would be just to rewrite this into slope-intercept form. So I could say, well, this means that y is equal to 1/2 x minus 1/2 plus 2, which is 1/2 x plus 3/2. So that means my y-intercept is going to be 3/2, which you could probably guess from looking at this graph, but this verifies it exactly. We know now that the precise value is 3/2. It's not something like maybe it was actually 1.53 or something just from looking at the graph, but this gives us the exact number. Now, what if I asked you to make a graph given something that is in point slope form? So what if I asked you to graph y plus 1 is equal to 2 times x minus 3? I don't think we've done an example like this before, where we give the equation in this form and I ask you to graph it. If I did, it's fine. We'll look at another one here. It doesn't hurt to see extra examples. So the first thing that I would do is I like to rewrite this as y minus y0 equals m times x minus x0. So this minus 3, that's fine because I'm already subtracting something, but this plus 1 doesn't really quite work for me. What I want to do is I want to rewrite this thing as y minus negative 1 equals 2 times x minus 3. So if you're adding one of these numbers, you can change that into subtracting a negative. Now, why do you want to do that? Well, the reason is because this is now my y0, this negative number. You don't necessarily have to do this. You can just remember that if this is positive, then the y0 is negative. If this is positive, then the y0 is negative. But, however you like to remember it, do whatever works for you. Now, my x0 comes from this. So the x0 is going to be 3. So my point is going to be 3 comma minus 1, and my slope is going to be 2. So when I make my graph, I know that I'm going to go through the point 3 minus 1. And I also know that the slope is 2, which means that if I go over by 1, I should go up by 2. And that brings me to the point 4 comma 1. And now I just have to join up those points, which I've managed to do in an incredibly messy fashion. But hopefully that gives you guys the idea. So if you are given a line in point slope form, this is one way that you can graph it. Another way that you could graph it if you wanted to would be to just rewrite the thing into slope-intercept form and do it that way using the slope-intercept. So it's up to you. There's a lot of different ways that you can do these problems, and they're all perfectly fine. They're all perfectly valid to do. All right, so this is a good place to take a quick break if you guys want to. And pause this, get up, stretch, walk around for a bit, take your mind off of this. What I want to talk about now is the relationships between standard form versus point slope form versus slope intercept form. So standard form for a line is ax plus by equals c. Slope intercept form is y equals mx plus b, and point slope form is y minus y0 equals m times x minus x0. But what are the relationships between all of these different forms? Well, really, the answer is that you just have to go through and you can rewrite your equation in any of these forms if you want to. So, for example, if I have something in standard form and I want to rewrite it in slope-intercept form, then I can do that. I just write by equals c minus ax, and that means that y is going to be equal to negative a over b times x plus c over b. So that means that this is my slope and this is my intercept. Another thing to notice is that slope-intercept form is actually point-slope form, where our point has an x-coordinate of 0. So we never really worry about going from slope-intercept form to point-slope form. What if we wanted to, and for the same reason, by the way, we never really worry too much about going from standard form to point-slope form. We just worry about standard form to slope-intercept maybe, and that's it. So what about slope-intercept over into standard form? Well, to go from slope-intercept into standard form, all I have to do is subtract the mx from both sides. So I would get negative mx plus y is equal to b. Now here's the thing. Often what you want in standard form, if you can, is you would like these to be integers. So usually what you would do at this point is if m is equal to p over q, then this would be negative p over qx plus y equals b, and you would rewrite this as negative px plus qy equals qb. That way all of these would be integers and these would be in standard form. What about point-slope form? Well, point-slope form, we can easily just solve for y and rewrite it in slope-intercept form, and then we could convert into standard form if we wanted to do that. So let's just run through a few quick examples of converting between different forms here. Let's suppose that I want to rewrite 4x minus 5y equals 6 in slope-intercept form. Well, effectively, all I'm doing is the procedure that we just did over here, which is really just solving for y. I'm isolating the y variable on one side of my equation. So this would become negative 5y is equal to negative 4x plus 6. And when I divide everything by negative 5, that gives me y equals 4/5 x minus 6 over 5. So the nice thing about doing this is that it might be a bit weird to just try to graph an equation that's in standard form, but if I rewrite it in slope-intercept form, now it becomes relatively easy to graph. We know how to graph things that are in slope-intercept form. Now, what if I gave you something that were in slope-intercept form, and I asked you to go ahead and to rewrite it in standard form? So what if I wanted to write y equals 2 over 7x minus 2 in standard form? Well, the first thing I would do is I would subtract the 2/7 x from both sides. So we would get negative 2 over 7x plus y equals negative 2. And then, in order to rewrite this having integer coefficients, I could multiply everything through by 7. So I would get negative 2x plus 7y is equal to negative 14. And that would give this to me in standard form with integer coefficients. Now, the good news for you guys is you don't have to worry about doing this rewriting stuff all that often. A lot of times, I would say for the applications that you're going to be interested in, you probably don't have to worry too much about things like standard form for a line. But it's good to know that it exists and that you can use it if for some reason it ever comes up. Mostly, you guys are probably going to be more interested in working with the slope-intercept form and with the point-slope form than you are with the standard form, though. So what we're going to do next time is to take a look at a few problems that you can do using using these lines, using linear equations, applied problems that you can solve by using them. And yeah, we're just going to look at a few applications of these things. Now, before I finish this, I want to mention in Blackboard, I uploaded a file into the extra study materials section. It's called lines.zip or something like that, and it's listed under something about lines. I don't remember what I called it exactly, but you look through there, there's not that many things. It's easy to find. This is a collection of 4 PowerPoints that covers information about lines that I was able to find. Now, it has some kind of silly pictures in there too. You can ignore those and just use them as a reference material to study about lines. And hopefully those PowerPoints will be kind of helpful to you guys as you practice and work through these problems. All right, so like I said, next time we'll be going over some applications, and I will see you guys then.